This is a continuation of Chapter 8, Lesson 2, and I'm on page 534, Example 4. It's the sine of the inverse cosine. And when you have a V, that is your ratio. Ratio, huh? All right. So I'm going to draw, and also when you have the inverse, you're always looking at the ratio. All right, so I'm going to draw a right triangle. If this is my theta or my u, they're using u, right? Then the cosine is the adjacent over the hypotenuse. So that would be v over 1. So I need to solve for this sine, and I use the Pythagorean theorem. V squared plus whatever squared, right, equals 1 squared. Well, 1 squared is 1. I'm going to subtract the v squared. So this side squared equals 1 minus v squared. To solve for that side, I take the square root. So this side is going to be the square root of 1 minus v squared. All right, it's just the Pythagorean theorem. So the sine of this angle is going to be the opposite over the hypotenuse. So that is going to equal the square root of 1 minus v squared over 1, which is just the square root of 1 minus v squared. All right, so when you have a problem like this, you're going to actually draw the triangle and do this ratio and solve for the other side. And it's just the sine of that same angle, that same piece of the part of the triangle. All right, now we're going to look at the inverse tan. The inverse tan is much like the inverse sine in that it looks in quadrants 1 and 4. Because remember, the tangent has these asymptotes at every odd half pi. So at pi over 2, it has an asymptote. At negative pi over 2, it has an asymptote. And the tangent curve looks like this. It passes the horizontal line test. So for the tangent, I'm going to limit my inverse tan to quadrants 1 and quadrants 4, exactly like the sine. All right, the tangent and the sine go together, quadrants 1 and 4. The cosine, quadrants 1 and 2. All right. So for the tangent, we're going to go, that's positive. For the tangent, we're going to go from negative pi over 2 to pi over 2. So if in example 5, I'm looking at the tan inverse of 1. I know at 1 it's positive, so we're looking in quadrant 1. I know the tan is always 1 at pi over 4 because the tan equals the sine over the cosine. It can only be 1 when the sine and the cosine is the same, and that only happens at pi over 4. It's square root of 2 over 2 over square root of 2 over 2. All right, so that this, the inverse tan, it's in the first quadrant, pi over 4. Look at B. Inverse tan of 136. Okay, unlike the sine and cosine, where this ratio is limited between negative 1 and 1, the tan goes from negative infinity to positive infinity. This is going to be in quadrant 1. I can do this in my calculator. So I do shift tan 136. I'm expecting that value to be in that first quadrant. And it is. It's really close to pi over 2. So it's 1.5634 radians. This is radians. I know it's strange to have just a number, but really, pi over 2 is really a number. Pi is really a number, right? All right. Now look at the properties. These properties for the tangent are on the bottom of 535. All right, let's look at these properties. These properties are just like the sine, all right? The inverse tan of the tan of any radians is going to equal the radians as long as that radians is in quadrant 1 or quadrant 4, between negative pi over 2 and positive pi over 2. All right, so if I did tan inverse tan and I said these radians were pi over 4, it would equal pi over 4 because that is in the first quadrant. All right, look at the next property. It says the tan of the inverse tan of any ratio is going to equal that ratio. Now with the sine, that ratio had to be between -1 and 1. That is not so with the tangent. It can be any number, any real number. It can't obviously be an imaginary number. So if I had the tan, the inverse tan of 1, it would equal 1. All right, so let's apply this with example 6. And then I'm going to work a few problems from your homework. All right, so it's the cosine of the inverse tan square root of 5 over 2. Square root of 5 over 2, when the inverse, we're looking in quadrant 1 and quadrant 4. This is in the first quadrant because it's positive. I'm going to draw the angle. I'll label it U. The tangent is the opposite over the adjacent. So this would be square root of 5 over 2. The cosine is adjacent over hypotenuse. So I need to calculate the hypotenuse. I'm going to use Pythagorean theorem. 2 squared plus the square root of 5 squared equals the hypotenuse squared. That's 4 plus 5 is the hypotenuse squared. That's 9. The square root of 9 is 3. So what does this equal? It equals 2 adjacent over hypotenuse. All right, I want to go and look at some of your homework. All right, look at number 8 on page 536. Applying all of this. Number 8 on page 536. It's the inverse cosine, square root of 3 over 2. Inverse cosine, I'm looking at quadrants 1 and quadrant 2. This has got to be in quadrant 1 because it is positive. And remember, the cosine starts at 1 and counts down. So it's 1 square root of 3 over 2, square root of 2 over 2, 1/2, 0. All right? So that square root of 3 over 2 is at that first radians past the 0, and that is pi over 6. So that would equal pi over 6. We will not put these in our calculator if this ratio is on the unit circle. All right? Now I want to go to 19. All right, it says, 19 says, the inverse sine of the sine of 7. All right, so this is radians since it is inverse, right? So where would 7 be? For the inverse sine, I'm telling myself I'm looking at quadrant 1, I'm looking at quadrant 4. Where is 7 on the unit circle? It's right, what is, we go, let's just do it, 0, pi over 2. Okay, that would be like between 0 and 1.5, right? And this would be pi, that's 3.14. This is 3 pi over 2. So that's what, like 4.5, between 4.5 and 5, all the way to 2 pi. So 2 pi would be, what, 6.28? 7 is 6.28. So 7 would actually go just right above 2 pi. So how do I find the radians then? I take this 7, which the radians here, and I want this angle. Because it goes all the way around and past it, I'm going to take the 7, I'm going to subtract 2 pi from it to get the radians in that first quadrant. Because when I'm doing the inverse, I'm solving for the radians, right? But it has to be in the first or the fourth quadrant. All right, so I'm going to take 7 minus, let me clear this out, 7 minus 2 pi. So that's your solution. Those radians have to be between 0 and 2 pi, and pi over 2, or 0 and negative pi over 2. So the answer is 0.7168. All right. And then I want to look at number 38. Number 38 on that same page. All right, so it's the tan, 38, Paula. The tan of the inverse sine of 3/5. All right. Inverse sine is in quadrant 1 and 4. Tan is in quadrant 1 and 4. Where's this? It's in quadrant 1. So my tan's going to be positive, right? If this were in quadrant 4, then my tan would be negative. I have to think about what quadrant I'm in. That dictates the sign. All right? So let's say that is our U. The sine is the opposite over the hypotenuse, right? This is a Pythagorean triplet. 3, 4, 5. The tangent of that same angle is equal to, tan is what? Opposite over adjacent. So it is 3/4. So in situations like this, just like the example in the textbook, you need to draw the triangle. It will be helpful if you draw the triangle. All right, last problem I'd like to look at is problem 45. All right, even when you have these variables, you want to draw the triangle. All right, anytime we have inverse, we're looking at a ratio. And so this is the tan of that same angle equals what ratio? We're still looking for the ratio. All right, it's positive. It's in the first quadrant. My tangent is going to be positive. All right, I draw the triangle. Here's the triangle. It's opposite over hypotenuse. Opposite over hypotenuse. I'm solving for this side. This is just like the example. We're using Pythagorean theorem. V squared plus that squared equals 1 squared. I subtract my V squared on both sides. That's 1 minus V squared. Then I take the square root. So this side is equal to the square root of 1 minus V squared. The tangent of this angle is the opposite over the hypotenuse. So it's going to be V over the square root of 1 minus V squared.